To say for section 7.3, we're going to do numbers 10 and 13. They use a different geometric mean theorem, similar to this, but a little bit different. The geometric mean theorem that's needed for these would be the one that uses the leg. So notice how in all of these red segments was the altitude to the hypotenuse. Notice how the altitude to the hypotenuse in both of these examples doesn't have a number given, and they don't want you to find it either. That's a dead giveaway that you're not going to use that theorem. You're going to use a different one. And the other one works like this. If you're looking at the big right triangle, one of the legs is the geometric mean. And it's going to be the geometric mean of the piece of the hypotenuse that it touches. So that would be this 4. And here's the other tricky part. The entire hypotenuse. So notice how we have a 1 there. We're not going to use the 1 in our proportion. We're going to use a 5 because that's what 4 plus 1 is. This entire blue segment has a length of 5. So x is the geometric mean of the whole thing, 5, and the piece of that whole hypotenuse that touches the red segment, 4. So we're going to cross multiply and solve here, and we're going to get x squared equals 20. That means x is the square root of 20. We can split square root of 20 into the square root of 4 times the square root of 5. The square root of 4 is a special number. The square root of 4 is just 2. There's no radical there. Square root of 5 does not simplify. There's no perfect square that goes into 5. So this is the answer here. This is 2 square roots of 5. 2 square roots of 5 is the geometric mean of 4 and 5. That's what that means. We're going to do the same thing for this number 13. We don't have the altitude to the hypotenuse. They don't ask us to find it. But we do have a leg of the big right triangle. That's going to act as the geometric mean. Now watch yourself. It's going to be the geometric mean of the small piece of that hypotenuse that touches it, and then the entire hypotenuse. So we end up with this proportion. The 4 needs to be in the geometric mean position. The green is z. Watch yourself here. The blue is z plus 6. It's this whole thing. And I can see already this is going to create some algebraic issues. We're going to do z times the quantity z plus 6. That's z squared plus 6z, and that's going to equal 16. If you subtract 16 from both sides, you end up with this perfect square trinomial. We need to factor it. So we did this in our lesson. Two numbers that will multiply together to give you negative 16. So how do you multiply two numbers to get a negative? Well, one of them's got to be negative. So make 1 plus 1 minus. Two numbers multiply together to give you negative 16, but when you add them you get positive 6. Think about some factors of 16. It's going to be 8 and 2. Your 8 will be positive, your 2 will be the negative because 8 minus 2 is 6. 8 times negative 2 is negative 16. So either this is 0 or this is 0 because you're multiplying two things together to get 0. So one of them has to be 0. So maybe z plus 8 is 0. That means that z is negative 8. Can you have a triangle length that's negative? No, you can't. So that means this guy's got to be 0. Z minus 2 equals 0, so z is positive 2. So all this mess right here, z is 2. Those are your geometric mean theorems where you have or you want to find a leg.